Hi, this is Mr. Max. I am continuing with my series on implicit differentiation, and I am doing a question that was in the paper of 2023, question 8. Now, um, the question says, or the statement says, a curve has an equation y cubed sine 2x plus 4y is equal to 8. We are supposed to show that, so we're just going to go ahead and let's write this down. So we are going to use implicit differentiation. So basically on the left hand side here, these two, you have the product of two functions. So what you're going to do is you are going to apply the product rule. And everywhere where you are differentiating y, you should attach dy dx. Just remember that. Okay, so this is d by dx of y cube sine 2x. I can separate them if I want to, plus d by dx of 4y. You don't have to do what I'm doing here, okay? But I just find it a little bit easier, especially if I have the products and or quotient rule and chain rules that I have to apply. Okay, so when we do differentiate this one here, we keep the first, multiply by the derivative of the second, which is the cosine of 2x, and then you multiply by the stuff inside by 2, plus the second sine 2x multiplied by the derivative of the second dy dx, plus now you have got 4y, and the derivative of that is 4 dy dx, and is equal to the derivative of 8, which is equal to 0. Now I also like to highlight so that I don't make mistakes. I like to highlight where I have my dy dx's, okay, and also the coefficients. So let me just write those coefficients down. So I have all the way here, I have 3y square sine 2x, okay, and that is going to be, let me just take the coefficient, plus 4. So this is the coefficient of saying dy dx, and I'm going to move this y cubed, this is 2y cubed, that is minus, if it comes there, minus 2y cubed cos of 2x. Okay, just make sure that is 2y cubed going that side is minus. So now you're going to divide throughout by whatever is in front of that dy dx, so that dy dx, which is what we are requiring to prove, is on its own. So I have minus 2y cubed cos 2x. All of this will be over that coefficient, so to speak. So you have got 3y squared sine 2x plus 4. Okay, right, we're just going to compare and see if this is what we were indeed supposed to prove. Let's look. So you had 2y cubed cos of 2x, yes, over 3y squared sine 2x plus 4. Okay, that is what we proved over there. Now, I'm just going to crop or take a snapshot of that. I'm going to take a snapshot of that. I could have easily have done the other one. Okay, so we're going to use that. Maybe it's not so nice. Let's maybe take the original one, because I'm going to use it in the B part of the question. Okay. All right. Now you would see that I also took the original function, which was y cubed sine 2x plus 4y is equal to 8, the original equation. So the reason for that is this is the gradient, this is m, okay, but they are saying find the gradient of the curve at a point where the curve crosses the y-axis. Now, what happens when something crosses the y-axis, if you can remember, you have, if something crosses the y-axis, okay, the y-axis, anything crosses the y-axis, at that point x is equal to 0. So we have a point x is equal to 0 to contend with, or to start with, so to speak. Now we have that one point, but our gradient function is given in terms of x and y, and that happens most of the time with implicit differentiation. So we need the corresponding y value. Hence, we take that x value, which is equal to 0, and substitute it into the function. Okay. Everywhere you have an x. Now, what's going to happen on this side? This is just going to be 0 because the sine of 2 times 0 is 0. Now, never mind whatever is being multiplied over it. So I'm left with 4y is equal to 8. And then from this particular instance, you should therefore realize that, wait a minute, y is nothing but 2. So the point that I'm going to differentiate with, or the point that I'm going to sub into my derivative function, dy dx, when x is 0 and y is 2, is going to be, let's just put brackets where I can before I do the substitution to avoid making mistakes. Okay. Okay, so let's substitute our values. So our x value is 0. So that is 0 and that is 0. Our y value is 2. So that is 2 and that is 2. Now, if you were to go on, this is 1, cos of 0 is 1. So you have got 8 times negative 2. Well, I believe that gives me negative 16. Of course, you can always check with a calculator. That's the numerator. And again, as I was saying, the sine of 0 here, 2 times 0 is 0. So this whole thing over here is 0. The only thing that I'm going to have left is 4. Therefore, the gradient is going to be negative 4. Okay. So when they ask us what is the gradient, that is what we are doing there. But of course, you could have used a calculator. But I mean, you should be familiar at this stage with cos of 0 and the sine of 0 as numerical values. Okay, now this is what I'm going to put up tomorrow. I'm going to do implicit differentiation. If you are following this textbook, you will see that I have plus minus 65 pages where I'm going to do questions on implicit differentiation, and all of the possible questions that are there. It's going to take me quite some time, and I'm also going to do at the same time parametric equations, and I'm going to explain also parametric equations, and so that you can be ready for the exam. So the notes are already set up for parametric equations and implicit differentiation to give you extra practice. So stand by for that tomorrow.